Hi students and friends, welcome to the channel Learn and Teach by Sir AYAZ. I will continue my video session for past papers, and this time I've selected 5070 October November 2023. The variant is 21. This variant is 21. So October November 2023. The total time for this paper is 1 hour 45 minutes. It's paper 2 theory. You can use calculator in this paper. Periodic table is provided in, in this paper. Total mark for this paper is 80. Here's question number 1. Choose from the list of compounds to answer these questions. So here's a list of compounds. You can see we have calcium oxide, carbon dioxide, carbon monoxide, lead chloride, propane 1-ol, sodium nitrate, sodium sulfate, sulfur dioxide, water. Each compound may be used once, more than once, or not at all. Identify the compound that A, a toxic gas produced by the incomplete combustion of carbon-containing compounds. There are two types of combustion. We have complete combustion and incomplete combustion. In case of incomplete combustion, the gases produced are carbon monoxide and water. Carbon monoxide is a poisonous gas, so you write carbon monoxide here. Part B, turns anhydrous copper 2 sulfate blue. So copper 2 sulfate exists in the hydrated form, and in the hydrated form it turns to blue. Hydrated form means water is attached to the compound. So in case of anhydrous, anhydrous means without water. It's white in color. So if you pour water to anhydrous copper 2 sulfate, it will turn to blue. So you write water here. C, let's do deoxygenation of water in reverse. This is related to eutrophication. Eutrophication is due to unintentional leaching or leaking of nitrates and phosphates in reverse. So in the choices, we can see there's a sodium nitrate. So it must be the right answer for this question. Part D, an aqueous solution gives a white precipitate on addition of acidified aqueous barium chloride. So barium chloride, when it reacts with the soluble sort of any metal like sulfate, it gives white precipitate. It usually gives white precipitate with sulfate. So sodium sulfate must be the right answer for this question. E, contains an anion with a charge of -1. So if you look at the salts here, we have lead chloride, we have sodium nitrate, sodium sulfate. So lead chloride, lead must be carrying +2 charge. Chlorine belongs to group 1. Here is chlorine. It's in group 7, sorry. And group 7 carries -1 charge. So you can pick this one, lead chloride. And in case of sodium nitrate, the nitrate ion, this is the nitrate ion, it also carries -1 charge. So you can pick this one also. So you can write either of these as your correct answer. Lead chloride or sodium nitrate. Question number 2. This question is about metals. A. Potassium is an element in group 1 of the periodic table. Copper is a transition element. State 2 physical properties of potassium that are different from those of copper. Here you have potassium, it's in group 1, this is group 1. And here is copper, it's among transition metals. So you know the difference between these two. The group 1 metals, they are soft. Group 1, soft, low density, low melting point, and you can even code the color gray white for group 1 metals. They exist as gray white or silvery solid. On the other hand, copper has higher density, higher melting point, it's hard. The color of copper is pink or reddish brown. So you can write any two of these. So they are saying two physical properties of potassium that are different. So potassium has lower density than copper. A has lower density than copper, or you can write lower melting point than copper. You can write any one from these. You can also write refer hardness. K is soft. K is soft or softer than copper. K is silvery white or gray white. Cu is pink or reddish brown. You can even write orange color for copper. B. Complete the diagram in figure 2.1 to show the electronic configuration of a potassium ion. Include the charge on the ion. So where is potassium? Here's potassium. It's in group 1. Proton number is 19, which means it must have 19 electrons. Now they are saying ion. When you're saying ion of group 1 ion, group 1, they form ion with the charge M plus. So it must be carrying plus charge here. So you have to write plus charge on right hand side. What about the electrons? Proton number is 19. Proton number is 19. It has lost one electron. Number of electrons. It has lost one electron. So you subtract 1. 19 minus 1 gives 18. So there must be 18 electrons. You know, in the first shell, the configuration is 2 electrons. You can write 1, 2. Second shell, you have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. There are 10 electrons now. 18 minus 10, 8. Now 8 electrons are left. Place it in the third shell. 1, 2, 3, 4, 5, 6, 7, 8. Number C. Table 2.1 shows the observations when 4 different metals react with cold water. We have metals cerium, potassium, uranium, vanadium. Observations for these metals are given. In case of cerium, it's bubbling slowly. Potassium, rapid bubbles form rapidly. Uranium, bubbles form very slowly. Vanadium, no bubbles seen. Put the 4 metals in order of their reactivity. Put the least reactive metal first. If you look at the table, then vanadium must be the metal with the least reactive behavior in this. So you will start with vanadium. And for the highly reactive one, it must be potassium. So I will write potassium for most reactive. Now compare the reactivity of other two metals, that's cerium and uranium. So uranium is forming bubbles very slowly. So it must be after vanadium. Then you will write cerium. This will be the final reactivity series for these metals. D, deduce the number of protons and neutrons in the copper atom shown. We have copper, 65 and 29. These two numbers are given. So 29 number is the atomic number. It's the smallest number. It must be the atomic number of proton number. So this must be the number of protons. Now, in order to calculate the number of neutrons, you have to subtract 29 from 65. 65 is the nucleon number. Nucleon number is the total number of protons and neutrons present in the nucleus of an atom. So you write 65 minus 29. 36. 36 must be the number of neutrons for this. E, in the presence of oxygen, copper reacts with sulfuric acid, H2SO4, to form copper 2 sulfate and water. Construct the symbol equation for this reaction. So oxygen, you know the formula of oxygen. Oxygen exists as O2. So I will write O2 plus, they are saying copper is reacting, so next reactant must be Cu. The third reactant is sulfuric acid, H2SO4. Now, what are the products? They are saying copper 2 sulfate. Predict the formula between copper and sulfate ion. In case of copper, they have mentioned 2, which means it's carrying +2 charge, or +2 is the oxidation state of copper here. What about sulfate? Its charge is -2. So ignore their charges. So we have 2, 2. 2, 2 will be cancelled out because these are same numbers. So we have 1. Swap these values. So you must be getting CuSO4. So CuSO4 plus water. Formula for water is H2O. Now let's balance this reaction equation. Oxygen is not balanced. Oxygen, on the left hand side we have 6 oxygen atoms, but on the right hand side we have 5 oxygen atoms. So if I will place 2 before O2, the number of oxygen will increase. So what I will do, I will place 2 before H2SO4. Now on the right hand side, 2H2O. In order to balance hydrogen on both sides. What about oxygen now? Oxygen is 4 plus 2, 6. Oxygen is again not balanced. So if we will place 2 before Cu and 2 before CuSO4. Now, count the number of atoms of each element in this. Oxygen on the left hand side, we have 2 here, and 2 multiplied by 4, 8. So 8, 9, 10. What about on the right hand side? We have 2 4s are 8, 8 plus 2. Oxygen is balanced. What about Cu? Cu is also balanced. On the right hand side, it's 2. What about SO4? It's also balanced. S is balanced on the right hand side. Hydrogen is also balanced. It's 4 on the left hand side and 4 on the right hand side. So all these elements are balanced now. F, copper can be used as a catalyst. Number 1, state how a catalyst increases the rate of a chemical reaction. It lowers the activation energy of the reaction or provides alternative reaction pathway. So you write lowers activation energy. Of the reaction. Part 2, name the catalyst used in contact process. This is something you have to learn by heart. It's vanadium 5 oxide. G. Give 2 reasons why copper is used in electrical wiring. One must be good electrical conductivity. Good electrical conductivity. And as they are saying, this is used in electrical wiring. So this must be related to the ductility of the metal. So you must be writing very ductile. Question number 3. Student investigates the reaction of small pieces of zinc with dilute hydrochloric acid at 25 degrees centigrade. The dilute hydrochloric acid is in excess. A. Complete the equation for this reaction by adding state symbols. Zinc is the metal. It must be existing in the solid state. For acids, we have to write aqueous because in water, they act as acid, or water is important to show their acidity. So I will write AQ. On the right hand side, they have already mentioned the state symbol for zinc chloride, which is aqueous, and H2. H2 exists in the gas state, so I will write G. B. Figure 3.1 shows the volume of hydrogen released as the reaction proceeds. So on x-axis, we have time in second. And on y-axis, we are having volume of hydrogen in centimeter cube. Deduce the time taken from the beginning of the experiment to collect 39 centimeter cube of hydrogen. 39 centimeter cube of hydrogen. So 39 centimeter cube, it must be here. So if you look at this line, it's coming here. And so it must be 150 seconds. So I will write 150 seconds here. The student repeats the experiment using dilute hydrochloric acid with a higher concentration. Now this time, the student is using higher concentration. All other conditions stay the same. Draw a line on the grid in figure 3.1 to show how the volume of hydrogen changes when dilute hydrochloric acid with a higher concentration is used. So you will definitely start from 0, but it must be more steeper. And the final line must be ending here. So I will use this one. This must be here. They are having high concentration, so I will write. So it become horizontal earlier than this line, previous line, because of higher concentration of hydrogen, hydrochloric acid. C. The student repeats the experiment at 30 degrees centigrade. All other conditions stay the same. Describe and explain using collision theory how the rate of reaction differs when experiment of 30 degrees centigrade is used. Now, previously, the temperature is 25 degrees centigrade, which means this time the temperature is increased. So definitely the rate of reaction increases. So you write rate of reaction increases. Now it's of 2 marks. So you need to write more points, as they said that you have to use collision theories. So in this case, particles have more activation energy or equal or more than activation energy. So you can write particles have more kinetic energy. Particles have more kinetic energy. So there'll be more successful collisions or more collisions. I'll write more collisions. You can even write more successful collisions or more successful collisions. Or you can write particles with energy equal or more than activation energy. Particles have energy equal to or more than activation energy. A sample of hydrogen is put into a gas syringe. The end of the gas syringe is then blocked so that no gas can escape. Explain using kinetic particle theory why decreasing the pressure in the gas syringe increases the volume of gas when the temperature stays the same. Suppose there's a gas syringe here. It's the initial pressure, initial position of this plunger. So what will happen if you will decrease the pressure? Again, there's a syringe. Now that you have decreased the pressure. You see the volume. This is a volume. First, this one is V1, initial volume, P1, initial pressure. Now the pressure is P2, V2. You see the difference? Initial volume, initial pressure. Now, if you decrease the pressure, so what's happening? You have decreased the pressure, decreased. So definitely you can see the difference, the volume increased, which increases, which means the distance between the particles also increases. So particles move further apart. Particles move further apart. Moving to next question. For A, concentrated aqueous calcium bromide is electrolyzed using graphite electrodes. Predict the product at each electrode. So we have concentrated aqueous calcium bromide. So calcium is among the highly reactive metals. So you can't get calcium as one of the product. Instead, you will get hydrogen. Hydrogen is below calcium in the series. So you'll, for the cathode, what you'll write? You'll write hydrogen. Now the solution is concentrated. So you must have having high concentration of bromide ions. So you, at anode, you will get bromine. B. Molten calcium bromide is electrolyzed using graphite electrodes. Construct the ionic half equation for the reaction at each electrode when molten calcium bromide is electrolyzed. So in case of molten calcium bromide, at anode, you must be getting bromine, that is Br2, and at cathode, you must be getting calcium. So the ionic equation, at anode, there will be loss of electron. So Br minus, you must be having Br minus at anode. It will lose electron. And the product is Br2 plus electron. Now let's balance the equation. We have two bromine atoms, so you have to place 2 before Br minus. And for electrons, you have to write 2 before E minus. Cathode, calcium is in group 2. Here's group 2, here's calcium. So it must be carrying +2 charge. So reduction will take place at cathode. So it will take 2 electrons. As you can see, there's a charge and calcium is +2. So it must be gaining 2 electrons to produce calcium. C. Describe a test for aqueous bromide ions. Include the observations for positive test. So we have test silver nitrate is used to test to check the presence of bromide ions. Remember, you have to use acidified silver nitrate. Acidified silver nitrate is used because we have to destroy any carbonate ion present in the solution because it will interfere with the results obtained. So you'll write for the test, add acidified silver nitrate. For the bromide ions, it must be giving cream precipitate. For bromide ion, the precipitate must be cream. This confirms the presence of bromide ions. Part D. Calcium reduces zinc ions to zinc. This is a reaction equation. Ca plus Zn2 plus gives Zn plus Ca2 plus. Number 1, explain in terms of the movement of electrons how calcium acts as a reducing agent in this equation. Now, reducing agent means it reduces the other species or reactant, reduces the other reactant. Now, how it's reducing? It's actually oxidizing itself. And you can see the change, Ca is to Ca plus 2, which means it has lost electrons. So you write calcium gives electron to zinc ions. Zinc, you see the change, 2 plus to 0, which means it indicates it has gained electron. So you write calcium gives electron to zinc ions. You can even write electrons getting transferred from calcium to zinc ions, or electrons transferred from calcium to zinc ions. Number 2, state the oxidation number of the Zn2 plus ion. You see the charge on zinc, it's 2 plus, so you write 2 plus. This will be the oxidation number of Zn2 plus. E. Sulfur dibromide is produced when sulfur reacts with bromine. Complete figure 4.1 to show the dot and cross diagram for a molecule of sulfur dibromide. Show only the outer shell electrons. If you look at the position of sulfur and bromine, Here's sulfur, it's in group 6, which means it must be having six valence electrons. 6 valence electrons for sulfur must be 6. What about bromine? Here's bromine, it's in group 7, which means it must be having 7 valence electrons. The formula indicates SBr2, that sulfur must be sharing 2 of its valence electrons with each bromine atom. And each bromine atom will be receiving one of these valence electrons to complete their valence shell. So, key for sulfur, it's up to you. You can take cross or dot. I'm taking cross. Bromine, then I have to take dot for bromine. Sulfur, 6 valence electrons. 2 electrons will be shared with each bromine atom. So I will write 1, 2, 3, 4, 5, 6. For bromine, I will use dot. 1, 2, 3, 4, 5, 6, 7. For another bromine, 1, 2, 3, 4, 5, 6, 7. This will be the final dot and cross diagram for part E. Question number 5. Part A. Figure 5.1 shows the displayed formula of compound A. Number 1, draw a circle around the functional group on figure 5.1 that is also present in alkenes. In alkenes, you know that it contains carbon-carbon double bond as their functional group. So it must be carbon-carbon double bond here. Number 2, deduce a molecular formula of compound A. So I can see carbon, hydrogen, and oxygen in this. So I will write CHO. Let's count the carbon. 1, 2, 3, 4, 5, 6. C6. What about hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oxygen 1, 2. So final formula must be C6H10O2. Compound A is a solid at 20 degrees centigrade. Describe the motion and arrangement of the particles in a solid. Now, in solids, the particles just vibrate about their fixed position. So you'll be writing vibrate or vibrating. So what the arrangement? They are tightly and closely packed or regularly. Tightly, closely, or regular arrangement. B. Alkenes react with hydrogen in the presence of a catalyst. Number 1, draw a circle around the type of reaction that takes place. Now, alkenes contain carbon-carbon double bond. This is a weak bond, and due to the presence of this weak bond, they can be easily broken down if they undergo addition reaction to give a single product. So, circle around addition. Number 2, name the catalyst used. In this case, the catalyst uses nickel. So I will write nickel here. Part C, figure 5.2 shows the structure of a compound B. Compound B can be polymerized. Draw 2 repeat units of the polymer formed when compound B is polymerized. So first of all, what I will do, I will draw the displayed formula of this compound in such a way that it becomes easier for you to draw a polymer formed from this compound. You see the double bonds are there. So double bond indicates it will undergo addition, polymerization. So this will be the initial structure. CH3, double bond, C, we have hydrogen here, and we have Cl here. Now they are saying draw 2 repeat units, the polymer form. You simply have to remove this bond. This bond must be removed, and I will convert this into polymer. So these will be the repeat unit for this one. One repeat unit. It must be single bond here. Second repeat unit. This will be the polymer form from this compound. D. Figure 5.3 shows part of the structure of a protein. 1. Name the type of monomer used to make proteins. Proteins are the polymers made from amino acids. So simply answer will be amino acids. If you'll break down these repeat units, this one, this one, this one, you will get amino acids. Name the linkage present in proteins. Now, linkage. This one will be the linkage. You can see it's repeated one after another. So this linkage is known as amide linkage. So you write amide. Number 6, the equation for the Haber process used in the production of ammonia is shown. This is a reaction equation. N2 plus 3H2, reversible sign, 2NH3. A1, the nitrogen for this purpose comes from the air. State the percentage by volume of nitrogen in clean, dry air. This is something you have to learn by heart. 78%. To state a source of hydrogen for the Haber process. So you can crack long chain hydrocarbons, or you can write the name of alkanes like methane, ethane, etc. B. The forward reaction in the Haber process is exothermic. 1. Explain in terms of bond making and bond breaking why this reaction is exothermic. Remember, bond breaking is endothermic. A bond breaking needs energy. So I will write bond breaking is endothermic and bond making is exothermic, or bond making gives energy out. Bond making is exothermic. Now this reaction is exothermic, which means more energy is released than absorbed, or you can write any opposite statement like less energy is absorbed than released. Number 2, transfer of thermal energy in a chemical reaction is called the enthalpy change. Write the symbol for an enthalpy change. Include the sign for an exothermic enthalpy change. So enthalpy change can be represented by delta H and sign is minus. C. Aqueous ammonia is an alkali. Aqueous ammonia reacts with dilute nitric acid to form a salt. Name this salt. So when ammonia reacts with nitric acid, it forms an ammonium compound. Remember, it's not ammonia, ammonium compound. So ammonium compound forms ammonium compounds. which means it must be having this sign NH4 positive, carrying +1 charge. What about the negative ion? So this is nitric acid. It will provide nitrate ion here. So the formula for nitrate ion is NO3. Also, it carries -1 charge. Ignore the charges and these subscripts will be exchanged. So the final formula must be NH4NO3. So it is ammonium nitrate. Ammonium nitrate. Part 2. Name the experimental technique used to make a solution of this salt from dilute nitric acid and aqueous ammonia. The experimental technique is known as titration. This involves the reaction between alkali and acid. Moving to next question, that is question number 7. A. Dilute ethanoic acid reacts with aqueous calcium hydroxide 2CH3COOH plus CaOH whole twice gives CH3COO whole twice Ca plus 2H2O. A student reacts 25 centimeter cube of 0.01 mole per dm cube aqueous calcium hydroxide with dilute ethanoic acid using thermophthalene as an indicator. A volume of 12.5 centimeter cube of dilute ethanoic acid reacts exactly with the 0.01 mole per dm cube aqueous calcium hydroxide. Calculate the concentration in mole per dm cube of the dilute ethanoic acid. I'm writing the reaction again here. So here's the reaction. 2CH3 COOH plus CaOH whole twice gives CH3 COO whole twice Ca plus 2H2O. Now let's write the number of moles of the reactants only. For example, for acetic acid or ethanoic acid, I will take N1 as its reacting moles. So here we have 2 moles of ethanoic acid. What about CaOH whole twice? For calcium hydroxide, I'm using N2. Here we have 1 mole. For volume of ethanoic acid, V1. For volume of calcium hydroxide, V2. For concentration of ethanoic acid, M1. And for calcium hydroxide, M2. Now, volume of ethanoic acid is provided, that is 12.5 centimeter cube. The volume of calcium hydroxide is 25 centimeter cube. What about the concentration? In the question, they are asking to calculate the concentration of dilute ethanoic acid. So we need to find this. What about the concentration of calcium hydroxide? It's provided 0.01 mole per dm cube. So the formula we are going to follow is M1 V1 by N1 is equal to M2 V2 by N2. Rearrange this equation. So we will get M1 is equal to M2 V2 divided by N2 multiplied by N1 by V1. Now placing the values of all these, M2 0.01, V2 is provided, that is 25. What about N1? N1 is 2 divided by N2 is 1. V1 is 12.5. 0.01 multiply by 25 multiply by 2 is equal to divided by 12.5. 0.04 mole per dm cube. This will be the final answer for this question. Part B. State the color of thermophthalate in aqueous calcium hydroxide. This is something which you have to learn. Calcium hydroxide is alkali. So in alkali, the color must be blue. C-ethanoic acid is a weak acid. Define the term weak in the phrase weak acid. The acid which is incompletely dissociated or ionized in aqueous solution. Acid which is incompletely dissociated or ionized in aqueous solution. Write the formula of the ion present in aqueous solutions of acids. So the common ion that all the aqueous solution of acid contains is H positive. Now part D, dilute ethanoic acid reacts with sodium carbonate. Here's the reaction equation. 2CH3COOH plus Na2CO3 gives 2CH3COONA plus H2O plus CO2. Calculate the volume measured at RTP of carbon dioxide produced in centimeter cube when 3.18 gram of sodium carbonate reacts with excess dilute ethanoic acid. Now the mass of sodium carbonate is provided. So we need to convert this into moles. So for this, we need MR of sodium carbonate, MR of Na2CO3. We have 2 atoms of sodium. So 2 will be multiplied by AR of sodium plus 1 atom of carbon, 1 multiplied by AR of carbon plus 3 atoms of oxygen. 3 will be multiplied by AR of oxygen. Sodium, here is sodium. 23 is its AR for carbon. Here is carbon. 12 for carbon. Oxygen, here is oxygen. 16 for oxygen. So I will write 23, 12 for carbon, and 16 for oxygen. So 2 multiplied by 23, we will get 46 plus 1 multiplied by 12 gives 12 plus 3 multiplied by 16 is 48. So adding up these, 46 plus 12 plus 48, 106. So number of moles of sodium carbonate, Na2CO3, number of moles must be 3.18 divided by 106. 3.18 divided by 106. So you'll get 0.03 moles of sodium carbonate. Now, I'm writing Na2CO3 for the reactant. And on the product side, we need to measure the volume of carbon dioxide. So the ratio is very simple. The ratio for the moles is 1 gives 1 mole of CO2. 1 mole of Na2CO3 gives 1 mole of CO2. Therefore, 0.03 mole gives X mole, which will become 0.03. And we know that at RTP, 1 mole of any gas occupies, at RTP, 1 mole of a gas occupies 24,000 centimeter cube or 24 dm cube. So in the answer, they are asking in centimeter cube. So I will take 24,000. So multiply 0.03 by 24,000. The answer 0.03 multiply by 24,000. 720 centimeter cube. This will be the final answer for this question. Moving to next part, E. Sulfur dioxide contributes to acid rain. One state one source of sulfur dioxide in the air. So it can be volcanic eruption, or burning fossil fuels containing sulfur compounds. Containing sulfur compounds. 2. Describe one method of reducing the amount of sulfur dioxide getting into the air. Can use low sulfur fuels. Using low sulfur fuels or flue gas desulfurization. Just remove the release of sulfur dioxide into the air. Instead, it neutralizes it. Number 3, in the contact process, sulfur dioxide reacts with oxygen. Complete the symbol equation for this reaction. Now, when sulfur dioxide reacts with oxygen, it produces sulfur trioxide. So the formula for sulfur trioxide is SO3. Let's balance the equation. We have 2 moles of sulfur. So I will write 2 here. On the product side, now this reaction is balanced. We have 2 sulfur, and for oxygen, 2 multiplied by 2 is 4. 4 plus 2 is 6. On the product side, it's also 6. So it's balanced now. Moving to question number 8. Ethanoic acid is manufactured from methanol. This reaction equation, CH3OH plus CO gives CH3COOH. The forward reaction is exothermic. Number 1, predict and explain the effect, if any, on the position of equilibrium when the pressure is decreased and the temperature remains constant. Remember, the effect of pressure is applicable to gases only. So let's count the number of moles of gases on both sides of this equation. On the reactant side, we have 1 mole of methanol and 1 mole of carbon monoxide. And this gives 2 moles on the reactant side. What about the product side? We have only 1 mole of the product. So there are less number of moles on the product side. So if you decrease the pressure, the equilibrium will shift to the side with higher number of moles of gases. You can also write higher number of volume of gases. So definitely position of equilibrium moves to the left. Now they are saying explain this. So you can quote the number of moles or volume of gases. So you have more moles on the reactant side or left side and fewer moles on the product side or right hand side. More moles of gases on left hand side or reactant side. Number 2, predict and explain the effect, if any, on the position of equilibrium when the temperature is decreased and the pressure remains constant. Now they are asking the effect of decreasing the temperature and keeping the pressure constant. Forward reaction is exothermic. So the forward direction, it must be favoring low temperature. So definitely the position will move to the right hand side or the product side. position of equilibrium, shift to right hand of product side. So for a reason, you can say forward reaction is exothermic. You can also write backward reaction is endothermic. Forward reaction is exothermic. B. Ethanoic acid can be produced by bacterial oxidation. Describe one other method of making ethanoic acid by oxidizing an alcohol other than methanol. Name of alcohol, it must be ethanol. If you oxidize ethanol, you will get ethanoic acid. And for the oxidizing agent, you can use acidified potassium manganate. Aqueous acidified potassium manganate. Mention the oxidation state of manganese here, 7. Moving to next question, that's part C. Ethanoic acid reacts with propane 1-ol, CH3, CH2, CH2OH to produce an ester. Name the ester and draw its display formula. What will be the name of the ester? So other name for ester is alkyl alkanoate. And the alkyl group must be coming from the alcohol. So we have propane 1-ol. So it must be propyl. So we'll start with propyl. What about the last name? Alkanoate must be coming from ethanoic acid. So here's ethanoic acid. So you write ethanoate. So propyl group, just remove the OH. Just remove the OH. So we have 3 carbon, 1, 2, 3. This one is the propyl group. For ethanoate, it will be coming from ethanoic acid. Remove H of ethanoic acid. Ethanoic acid is this, CH3, COOH. Remember, you have to remove hydrogen of the acid, acidic hydrogen. This hydrogen must be removed. Now I am drawing the displayed formula. And these will be united through ester group. O, single bond, C, double bond O, and we have CH3. This will be the final displayed formula for this one. Question number 9A. Table 9.1 shows the melting points and relative electrical conductivities of 3 elements. We have carbon, graphite, magnesium, phosphorus. Melting point and relative electrical conductivity of solids provided. Use ideas about structure and bonding to explain the difference in the melting points of magnesium and phosphorus. Now they are saying structure and bonding. So magnesium, it has giant metallic lattice and sea of delocalized electron. That's why it has high melting point. So you will start magnesium has high melting point because it has a giant metallic lattice. Remember, you have to write metallic lattice because it's a metal. Metals contain metallic lattice and sea of delocalized electrons and sea of delocalized electrons. Now, other element is phosphorus. Now, phosphorus, they have low melting point. If you look at the melting point of phosphorus, it's 44. So it has low melting because they are weak forces between the molecules. You can even mention phosphorus has weak intermolecular forces. Phosphorus has low melting point because it has weak intermolecular forces. Moving to next part, the difference in the electrical conductivities of graphite and phosphorus. Now graphite, it's a good conductor of electricity. You can see relative conductivity of solid graphite. It's good. Phosphorus, it's poor. It's definitely due to the presence of mobile or delocalized electrons. On the other hand, phosphorus does not have any mobile electrons. So you will write graphite has delocalized mobile electrons. Phosphorus does not have. Phosphorus has no mobile electrons. Part B. Diamond and graphite are different forms of carbon. Explained in terms of its structure and bonding why diamond is used in cutting tools. Diamond also has a giant structure of covalent bonds, or it has strong bonding between all atoms. Diamond has a giant structure of covalent bonds. Diamond has strong bonding between all the atoms. Last question. A compound of phosphorus, oxygen, and chlorine contains 20.2% phosphorus, 10.4% oxygen, and 69.4% chlorine by mass. Deduce the empirical formula of this compound. So we have phosphorus, P is the symbol for phosphorus, oxygen O, chlorine Cl. Phosphorus is 20.2%, oxygen 10.4%, chlorine 69.4%. We need AR for phosphorus, it's 31, oxygen 16, chlorine 35.5. So 20.2 divided by 31, oxygen 10.4 divided by 16, chlorine 69.4 divided by 35.5. 20.2 divided by 31, 0.651. 16. Oxygen 10.4 divided by 16.65. Chlorine 69.4 divided by 35.5. 1.954. 1.954. Small mole ratio in this is 0.65. So I will divide all by 0.65. For phosphorus and oxygen, it will be 1, 1. Chlorine 1.954 divided by 0.65. So 3. So the empirical formula must be POCl3. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.